Today we are diving into one of the strangest and most profound ideas in science and philosophy, the Anthropic Principle, the notion the universe must allow observers like us to exist within it, and that this simple fact might explain why reality looks the way it does. Where philosophers like Nick Bostrom ask if our entire reality might be a digital reconstruction, an ancestral simulation run by some higher civilization. And then there's the doomsday argument, which suggests that statistics alone might predict the end of humanity, not from any disaster, but from the odds of when you happen to exist in the grand timeline of our species. Each of these questions about the end of the world, the origins of creation, or the reality of existence draws on the same deeper puzzle. What does it mean that we are here to ask them at all? Possibly more importantly, they each have two traits. First, they're very interesting topics since they essentially ask, is there a God? Is this real, and are we doomed? Which are all pretty provocative subjects. The second is they make for great thought experiments, as they are more or less impossible to prove either way from available data, and it's very hard to gather more data relevant to their answers. A key thing about the Anthropic Principle and the Copernican Principle is they are both about how you draw decent conclusions. We don't have much data and don't have an easy way to get more of it, and it tends to spoil a thought experiment or practice with either if students could always raise their hand and say, why don't we get a few more samples before we decide? But it is rather difficult to gather more samples of other universes with less life-friendly physical constants for a fine-tuned universe, or to see if there's a higher layer of reality for a simulation hypothesis, or to jump ahead in time and see what the last census for humanity says and the date on the last tombstone. We will discuss these more, and again, they each have their own episode, but the Anthropic Principle is the thread running through all three. It's the idea that observation itself creates a kind of filter. You can only see events if you're present for them, and sometimes the reason why you are present is also the reason for the given event or arrangement. From Copernicus to the Anthropic Principle. There is no firm date when science began, but in physics, we tend to say the first physicist was Copernicus, then Tycho Brahe, Kepler, Galileo, and Newton, as sort of the original five, and science was born. Newton was born 100 years after Copernicus died, and by his time, science was well established. There was no one person who deserves the credit, and Francis Bacon, Gottfried Leibniz, René Descartes, and many more, some even before Copernicus, deserved credit, but Galileo and Copernicus both have a special role in things. Copernicus pushed us to accept the Earth was not the center of the universe, though ironically it is the center of the observable universe, and Galileo to the critical concept that the rules for reality down here on Earth were the same as in the heavens above. You fall to the ground for the same reason the planets orbit. Science often begins with humility, the admission that we are not at the center of things or special. That shift began in earnest with Copernicus, who dethroned Earth from the middle of the cosmos and replaced it with the Sun. A few centuries later, the telescope in physics finished the job, showing that we were just one pale blue dot of a planet orbiting an average star, in an average galaxy, drifting through an unfathomably large universe. That worldview evolved into what's called the Copernican Principle, or more generally, the mediocrity principle. If we have no reason to think we are special, we should assume we are typical. At the basic level, as you gather more data, you'll see an increasing likelihood of accuracy about how normal or rare you are. But if you've only met one human and they are 7 foot tall, you would be quite wrong to assume they are average. But it is the conclusion from the Copernican Principle. Take 100 random people and pull one of them out of a hat to meet, and more often than not, they are going to be fairly average. So it is a good approach when you haven't got a lot of data yet. Of course, it is better to get more data, but even then, you can meet 100 people in a row who are each in the top 1% of the human height range, and at random that would be 1 in 100 to the 100th power, which would be 1 followed by 200 zeros. Not very likely, but not actually impossible, and inevitably some people are going to pull statistically improbable samples. Roughly 1 in 1,000 people are going to flip a coin 10 times in a row and get heads each time, and incorrectly assume the coin was biased. Of course, if you visit Earth and meet such a group of people, all very tall, you might be advised to ask if there's something filtering the result, like you landed at a basketball tournament. And I want to emphasize both the mediocrity principle and the Anthropic Principle, while usually discussed in grand astronomical or philosophical terms, are themselves very mundane and familiar concepts. As an example, a lot of us have friends or partners who are statistically unlikely to have quite so many shared interests with us, taken at random, but it wasn't random. You and Johnny have a shared interest in comic books, and you met at a comic store. That wasn't a very random meeting, and you both love Dungeons and Dragons, but that's because Johnny convinced you to play a few years back, and you come to enjoy it. It's also not shocking that if you were to survey a random population of folks to see who likes comic books and who likes D&D, you might get 1 in 10 and 1 in 20 people respectively, and thus by random odds, you'd expect only 1 in 200 people to like both. But find out that it was more like 1 in 40 because they overlap a lot. There's a correlation. What makes all cosmic examples seem a lot deeper is scale, and again that inability to get more data easily. Without giant telescopes, there was only one Earth-like planet to see, this one. So by mediocrity principle, it's probably an average one. If there's only one species like us, we're probably a sample of the norm. It's not arrogance, it's actually quite the opposite. It's a method of reasoning that says the simplest explanation is that we are ordinary until proven otherwise. But then the Anthropic Principle comes along and politely disagrees. It says that when you're trying to understand why the universe looks the way it does, you cannot assume you're a random sample of observers, because your ability to observe it at all depends on the conditions that make you possible. It's a small change in perspective, but one with big implications. If the universe were even slightly different, if gravity were stronger, the stars would burn out faster. If the electromagnetic force were weaker, atoms would not bind. The cosmos wouldn't have life, let alone anyone to measure those constants. So, when we look out and marvel that everything seems just right for us, the Anthropic Principle gently points out, of course it does. In any universe where it wasn't, there'd be no one there to ask why. That's a profound idea, but also a dangerous one, because once you start explaining things by saying, we're here because we can be, you risk turning a scientific mystery into a tautology. It's the ultimate just so story. The universe must look this way, or we wouldn't be around to notice. And while that's logically sound, it doesn't actually tell you why it is that way. Moreover, something being logically sound or logically coherent does not make it right. Indeed, the biggest difference between the ancient philosophers and the rise of modern science was realizing you need to gather data because so often what seems logically reasonable would turn out wrong because you were missing factors you just couldn't see until you started getting real data. This, incidentally, would also apply to a super-intelligent AI. If one came into being, it can't just automatically make huge leaps in science and technology without actually gathering data by building experiments. This is why, when we discuss the Fermi paradox, I tilt toward the solution that intelligent technological life just very rarely evolves. I like to say I view it as the least bad of the available solutions. Our knowledge of other planets is very minimal even now, and our geological and biological history of this planet is pretty thin too. We just don't have the deeper understanding necessary to make conclusions or assertions stick. And moreover, the sheer number of question marks, unexplained and poorly understood phenomena, and the vastness of unknown unknowns makes it quite reasonable to think that there's a high chance some of our core assumptions about life, the universe, and everything are wrong. In that sense, the Anthropic Principle sits uneasily between science and philosophy. It's not a theory of how the universe works, but a lens for reasoning where we can't easily gather more data. It's a way of saying, given the limits of what I can observe, what conclusions can I even draw? That's what makes it so powerful and so prone to misuse. It reminds us that our perspective is biased simply by existing, but also tempts us to use that bias as an excuse for not looking deeper. And that brings us to the doomsday argument, one of the most famous and controversial applications of this kind of reasoning. It takes that anthropic bias and adds a dose of statistics to it, suggesting we can predict humanity's fate from our own place in the timeline. But before we dive into that, we will need to pause to talk about what probabilistic reasoning really means, and why it can both enlighten and mislead us when applied to questions as vast as the fate of the human race or the lifespan of the universe itself. The Anthropic Family Tree. The Anthropic Principle was first named and formalized by astrophysicist Brandon Carter in 1973, appropriately enough at a conference celebrating Copernicus. The basic concept predates that, and we can see some early nudging at it by everyone from Leibniz to Kant and Boltzmann and more. But Carter formalized it, and Carter's background in cosmology presumably shaped the way he framed the idea, not as a mystical statement about purpose or a mundane bit of reasoning about the observer being there to see something anomalous because they are part of that anomaly themselves, but as a practical tool for reasoning about a universe we could barely sample. After all, astrophysicists spend their careers studying the largest systems imaginable, most of which they can never touch, visit, or replicate. So it's not surprising that Carter's formulation was about how to draw conclusions with almost no direct data. I should also emphasize that this is not quite the same as either selection bias or observer effect, where you might, for instance, use a fishing net to sample the ocean and thus miss anything too big for your net or too small to be stuck in it, or that your presence alters the experiment. You're studying something and it's cooled by being in your shadow, or warmed by what heat you give off. He called it the Anthropic Principle from anthropos, meaning human, though he later noted the term was a bit misleading. It's not about humans specifically, but any observers at all. The principle comes in several flavors, but they all circle to the same idea, that the universe's apparent fine-tuning and our existence as observers are not separate facts, they are connected. Carter first divided into two types. First, the weak anthropic principle, WAP, the modest version, which says our observations of the universe are biased by the fact that we exist. We shouldn't be surprised to find ourselves in a universe capable of life, because only such a universe could contain us. It is a reminder that any observation comes pre-filtered through our own existence. You can't see a dead universe. Second, we have the strong anthropic principle, SAP, the bolder cousin, which says the universe must allow observers to exist. That sounds almost teleological, as if the cosmos is required to produce intelligence somewhere, sometime. Carter did not mean it as theology, though it certainly became a common theological discussion point since. But instead he meant it as a statement about logical necessity. If a universe could never generate observers, it would never be known to exist in the first place. Later, cosmologists John Barrow and Frank Tipler expanded these ideas into what they called the final anthropic principle, FAP, a grand extrapolation suggesting that once intelligent life arises, it will never truly disappear, that intelligence will endure, adapt, and ultimately find ways to persist forever. This also connects up to quantum observer effects. Whether you read that as science, philosophy, or optimism depends on your mood, but it certainly completes the arc from modest observation to cosmic destiny. This is also my own first encounter with the idea. They wrote a book on it in the mid-80s that I encountered a few years later as an avid young reader. I devoured all the kids' books on astronomy at my local library and moved on to the adult content, which was mostly over my head, and in later years I would find out a lot of coffee table physics books, even well-known ones, were fairly fringe theories. This is often still true, but sorting them out later in life when I had a formal education in physics really helped shape my critical thinking, as did reading a lot of philosophy, which is why I tend to be much more willing to discuss more edge-of-science concepts on this show without sneering at them. I find them fun to contemplate and good for sharpening the mind, so we just say what the known pros and cons of a theory are. On the topic of philosophy, while Carter deserves credit, and Tipler and Barrow and others too, it was philosopher Nick Bostrom who really formalized the concept properly, and he would later catalog over 30 distinct versions of the anthropic principle, from the pragmatic to the metaphysical, and add a few of his own. This is why when discussing the concept I always try to emphasize that it is not just the cosmic version and a near synonym for fine-tuned universe. Some, like his self-sampling assumption, SSA, and the self-indication assumption, SIA, refine what we think about probability and observer selection. Under the self-sampling assumption, you should reason as if you are a random sample from the set of all observers who actually exist. This means your own situation, where and when you find yourself, should be considered typical among those observers. You are at a random and mundane point in the crowd. It's the logic behind the doomsday argument, which suggests that if humanity were destined to have trillions of members, you'd expect to find yourself somewhere deep in that long timeline, not so near the beginning. Being early implies a smaller total population. To me, this has always been a great example of the flaw of probabilistic reasoning, particularly when all your observations are limited to one section of sample, in this case early-era humans, but we could as easily say drawing deep in universal biological principles when your only example are those you studied on one desert island you crashed on and without the aid of a microscope. The doomsday argument, though, tends to fascinate me and a lot of other folks, and I think a lot of people feel like the end is relatively nigh, and thus it feels more factual to them, whereas I tend to assume the human population, or human descended or originated person, is likely stretching to many quintillions of people being alive at any given moment and lasting many trillions of years, and thus it just seems like an example of good logic leading to bad conclusions. And again, that happened a lot in pre-science times, which is why it's so important to gather data. Anyway, we also have the self-indication assumption, SIA, which flips the reasoning of SSA. It says your very existence provides evidence favoring universes that contain more observers rather than fewer. Imagine a cosmic lottery where every conscious being is a ticket. The more tickets there are, the better odds that one of them will be you. So if reality can exist in either a small, sparsely populated universe, or a vast one filled with countless civilizations, SIA says the second option is more probable because it offers far more opportunities for your consciousness to appear. If you only have two cities, one a small town and one a metropolis, a random person selected from that population overall is much more likely to be in that heavily populated metropolis. In this view, existence itself votes for abundance, for multiverses, for alien life, for simulated minds, for any scenario that multiplies observers. It's a reasoning that sounds wonderfully optimistic until you realize it could imply that most conscious beings are not biological at all, but artificial ones inside simulations or alien machines. There is also a tendency in this reasoning to view our universe as fertile ground for intelligent life. I think that comes from the default notion of many physicists in the 60s and 70s to assume space travel was just really hard and nuclear weapons very easy, and this explained our lack of alien contacts. They were out there pretty far away, and only on one world and maybe not for long. That was the default assumption of the Fermi paradox, but biologists tend to be a lot more skeptical about life and intelligence arriving everywhere, and with the success of Apollo and the Cold War never escalating, we get the idea that since life is generally going to be hardwired to want to explore and expand, we should expect technological civilizations to figure out how to do this if it is possible, and if they do it before wiping themselves out, then they are very hard to wipe out going forward, being scattered among many worlds, and ever expanding until they bump into someone else. And this becomes our other default Fermi paradox solution, that since we don't see life all over the place, spacefaring civilizations probably do not pop up much. In the absence of verifiable alien intelligence, or a functioning human-made interstellar spacecraft, or a functioning interstellar colony, neither position can really be said to have strong evidence. In short, Carter gave us the name, Tipler and Barrow expanded its scope, and Bostrom built the philosophical architecture around it. But we do have other versions too, like participatory Anthropic Principle, inspired by physicist John Wheeler, which suggests that conscious observation does not just reveal the universe, but helps bring it into being. And there are a lot of schools of thought in quantum that a conscious mind must be involved in determining events, like the result of Schrödinger's cat. And like a lot of these sorts of topics, it is unprovable either way at the moment, since I don't know how we could make an observation that didn't involve us observing it. You could make an entirely automated experiment that cataloged data and not look at it for a century, but you still eventually had to look at those results to know them, and now a conscious observer was evolved. Bostrom's most famous contribution, of course, is the simulation hypothesis, which reframes the question entirely. Instead of asking why the universe's constants seem fine-tuned, it asks whether those constants were chosen by design, by programmers, not by physics. This can obviously be rephrased as by God, capital G, or gods, or incredibly powerful or intelligent beings. It's functionally identical, but I think we tend to feel programmer removes some of the emotional charge from the topic, while also letting us use video games and virtual reality as familiar examples. Though I will note that the options available to an infinitely powerful being compared to a very powerful but finite being are very different in terms of what the usage might look like. For instance, an all-powerful being has no need to limit or compress how much mind it's giving to its various NPC actors. Needless to say, at this point, the Anthropic Principle starts to look less like a single idea and more like a sprawling family tree of philosophical thought experiments, some grounded, some speculative, all wrestling with the same uncomfortable realization that our existence is not a neutral fact. It changes what kind of questions can even be asked. When you mix this kind of observer bias with statistics, you get something especially provocative, the doomsday argument, a mathematical attempt to predict humanity's future from our own place in the cosmic roll call. To understand how that reasoning works and why it's both fascinating and flawed, we need to take a closer look at how probabilistic arguments function in science, and where they can lead us astray. Simple examples before the cosmological ones. While the Anthropic Principle can sound lofty, it really describes something we all experience in daily life, drawing conclusions from limited information while forgetting how much our own perspective shapes the sample. Imagine you're at an event and notice that everyone around you seems unusually good at mental math, cautious about risk, and oddly obsessed with actuarial tables. You might think the world is full of cautious number crunchers until you realize your sample came from an insurance convention. The Anthropic Principle is the same concept. When we have a set of samples, we need to consider the possibility that this was not truly random, but connected to our own presence. Your first meeting with alien intelligence is likely to include a lot of people who are disproportionately curious, because that's who you sent as your explorers or who they sent as theirs. Both the mediocrity principle and anthropic principle are reasoning tools for cases where data are scarce. The first says, assume you're average until proven otherwise. The second says, remember, you can only sample from situations that allow you to exist. Either way, you're navigating uncertainty. It's not unlike the Dunning-Kruger curve. When you know very little, you may feel overly confident. As you learn more, you realize how deep the unknowns go. Early on, people feel a little confidence from very little knowledge, but then we get to a confidence peak while still fairly ignorant. I like to refer to this as the peak of Mount Stupid. And most of us vacation there from time to time. Some folks seem to have permanent cabins there too. But we should be especially mindful that, for all we know about the universe these days, we haven't actually gotten much hands-on data from any place besides Earth yet. We don't know that our universe is really the sum of all that is, was, and ever will be. A big question today is why things look the way they do here on Earth, and for a gorgeous reminder of just how grand and detailed that past is, check out Joe Scott's new documentary, Oldest and Newest Places on Earth on Nebula, jumping from the 4 billion year old Acosta Nice to volcanoes creating land even now. Many of you already know him from Answers with Joe. Now join him on a 4 billion year journey of Earth in the making. And you want a mind-bending look at deep time? This month's SFIA Nebula exclusive is Chrono-Engineering, Manipulating Time as Technology, what physics already allows, what it might allow someday, and what happens to fate and free will if it becomes an engineering variable. Nebula is the home of amazing content from many awesome creators, where every episode of SFIA shows up early and ad-free. And right now, you can get a 3-day free trial and 50% off your membership. Just use my link with the QR code, go.nebula.tv/IsaacArthur. Boltzmann brains and the limits of observation. And that brings us to one of the strangest examples of all, the Boltzmann brain. In the late 19th century, physicist Ludwig Boltzmann proposed that our ordered universe might just be a rare statistical fluctuation in an otherwise chaotic cosmos. That given infinite time, even improbable things will occasionally happen by chance. The anthropic twist comes when we ask, if that's true, why do we find ourselves in a vast, structured universe instead of a lone, momentary brain drifting in the void, hallucinating a reality that isn't even there? Statistically speaking, it would take far less energy and improbability to assemble a single conscious brain, complete with false memories, than to build an entire universe filled with galaxies, and even less to get some sort of basic self-growing proto-mind that could build itself into a larger brain rather than an evolutionary approach. Or so goes the reasoning. Now, Boltzmann was working in the 19th century when the default assumption was the universe was probably infinite in all directions and time, and homogeneously distributed. That is no longer thought to be the case, but the nature of the anthropic principle on cosmological scale is that it assumes there are a huge number of life-unfriendly universes out there in a wider multiverse, and also opens doors to greater timescales, not just variations on our own Big Bang. So what we really mean is a huge number of evolution-unfriendly places where the physical constants do not permit stable chemistry to occur in any abundance or over long timescales. You could probably build life or a mechanism that would function in such a universe, if not realistically evolve there, but if it can be built by artifice, it can, in a big enough sample, occur by random chance. We do not, incidentally, have any clue what the odds are for a livable universe like ours to arise, or what the odds are for a minimum necessary Boltzmann brain, only that both probabilities are astronomically small. You will sometimes hear figures like 10 to the 120 for a fine-tuned universe, plausible enough but entirely speculative, and related values for the cosmological constant, and we could include more factors. But if true, to put that in perspective, that would make life-friendly universes rarer than a single atom among all the particles in our own cosmos. As to calculating the odds of a brain like ours assembling at random, that can only be meaningfully done in a reality that already allows for our kind of chemistry, which would be a tiny minority of possible universes. Moreover, we don't know how small such a brain could be to start. It might not need to begin at a human-level intellect, or even as a full brain in our sense of the term. It might simply need the potential to expand or self-organize, an easier random outcome than forming a twice as large brain to begin with. Still, there's no reason to assume a Boltzmann brain must start sane. Quite the opposite, the overwhelming majority of them would almost certainly be utterly incoherent, lacking functional sensory organs, and trapped inside their own mad dreams, should they be unlucky enough to have any self-awareness at all, or the ability to keep themselves alive long enough to starve to death. So if we take pure probability seriously, most observers should be such fleeting minds, Boltzmann brains, not evolved beings like us. Yet we clearly experience a coherent world that persists whether or not we are paying attention, which suggests that either our assumptions about probability are wrong, or our universe is special in ways that rule those nightmare scenarios out. In a more interesting hybrid example, I would be curious what the odds of a self-growing mind around a stellar-scale power source would be, a Matryoshka Boltzmann brain, though one that might begin not much bigger than an amoeba, as in simulation hypothesis terms, that could meaningfully simulate untold quintillions of minds and multiple full-scale universes, and it isn't too unreasonable to assume that the internal mental landscape might continuously tweak itself to feel consistent and reasonable. And now you are faced with natural and mostly dead or near-dead universes versus a tiny rare but massively populated set of subverses on rare Boltzmann megabrains. In that sense, Boltzmann brains highlight both the power and peril of anthropic reasoning. If you push it too far, you can start to explain anything, even absurdities, simply because you're there to perceive them. Of course, they might not actually be absurd. All in all, we are probably wise, not arrogant, to assume Earth and humanity are pretty exceptional rather than a mediocre example of a planet or species, while still acknowledging that we might be rather mediocre by the standards of intelligent beings and life-bearing planets. For all we know, we might be mediocre because we are literally the only sample there is, not just the only one we've encountered. The Anthropic Principle lives in that space between ignorance and humility, where our knowledge of the universe is vast enough to pose the right questions, but still too limited to expect final answers, and both it and the Copernican Principle are crude tools compared to proper analysis of larger datasets. But for now, they're all we've got, besides our curiosity, of course.